Hello, welcome back. It's been a while. It's good to see you again. So today I have something fun planned for us. I wanted to test your thinking abilities with some riddles, logic puzzles, brain puzzles. I pulled it from this game, Visual Brainstorms, the Smart Thinking game. Found it. This is my mom's basement. They're these little cards. They've got fun little drawings on them. And they come in varying difficulties. Easy, hard, and very hard. Apparently, they don't do moderation. I picked the ones that you don't have to look at the pictures. So some of them, it's like, it's like a maze. Like, can you find your way out of this maze? Or like, which two-dimensional shape will fold into this three-dimensional shape? But I wanted you to be able to close your eyes if you'd like, or lay down. And so I'll show you the pictures, but these don't require that you look at the pictures, the ones I picked out. So, these are the ones I picked, and we will just see how many you can get, and we'll work through them together if there's any you can't get, or any you need help with. Okay, so, and I already filmed this video in its entirety without my mic plugged in, so we'll start with the first one. So here's the picture. It's Lauren. I'll read it to you. Lauren's latest entrepreneurial venture is raising potbelly pigs and ostriches for fun and profit. Not very vegan of her. Among her animals, she has 17 heads and 56 legs in all. How many pigs and how many ostriches does Lauren have? So, 17 heads and 56 legs. Now, there are a couple ways to solve this. I will start with the way I solved it, and then when I looked on the back, they have the answer and the kind of like method. The method they used is slightly different, so I'll show that one next. So basically the way I saw this was a simple algebra word problem. So started with 4p plus 2t equals 56. So for 4, p representing the amount of pigs and t representing the amount of ostriches. So 4 legs per pig, 2 legs per ostrich equals 56 legs, and then p plus t equals 17 heads. So we're required to use a little bit of inductive reasoning here because it doesn't specify that every pig has 4 legs, every ostrich 2 legs, and each animal 1 head, but based on our world experience, we can assume as much. So we're going to assume as much and set the problem up this way. And so to isolate one of the variables, I'm going to subtract p from both sides. So I'm going to get t equals 17 minus p. So then now we can sub in 17 minus t for p and get an equation that only has p. So now, then I'll show you kind of what I have. So 4p plus 2 times 17 minus p equals 56. You get 4p plus 34 minus 2p equals 56, and then 2p plus 34 equals 56. So I just then subtracted the 2p from the 4p, so 2p plus 34 equals 56. So then we get, if by subtracting 34 from both sides, 2p equals 22. Divide that by 2, p equals 11. So through that, we know that there are 11 pigs. P equals 11. And then we can simply sub that back in. So p plus t equals 17, t equals 6. That means there are 11 pigs and 6 ostriches. If that makes sense. And here you can see it twice from the 2 times I filmed this. And if we go ahead and check the answer, is that what you got as well? Let's see if your way was similar to this way. So yes, there are 11 pigs and 6 ostriches. Here's how. Each animal has 2 hind legs. So 17 heads means 34 hind legs total. The remaining 22 legs must be the front legs of 11 four-legged pigs. Therefore, 11 heads belong to the pigs, and the 6 remaining heads belong to ostriches. So, yeah, that makes sense. That was a much easier, straightforward way of doing it. But, of course, when I first read it, I kind of saw it as like a math problem, so. Okay. Next. Clarence. Let's take a look at Clarence. This is Clarence and his fish barrels. So, Clarence's favorite joke is to switch the signs on fish barrels. So, he has a very interesting sense of humor. Today, he mixed up the signs on the carp barrel, the catfish barrel, and the carp and catfish barrel, deliberately hanging each sign on the wrong barrel. Clarence will let you see only one fish, but it can be from any barrel you choose. Using only this information, how can you restore the signs to their rightful... Using only this information, can you restore the signs to their rightful barrels? And if you can, how? So from these 3 barrels, is it possible to know where the rightful signs rightfully go? And which barrel would you choose to see one fish from? My intuition is the same. Yes. Yeah, so then you would... Well, let's see if we're right. So yes, the answer is yes, you can. So start by choosing a fish from the carp and catfish barrel. So you were right about that. Since every barrel is incorrectly signed, you already know that this barrel cannot contain carp and catfish. It has to contain only one type of fish. So let's say you pull out a carp from the carp and catfish labeled barrel. You can then correctly place the carp label on this barrel. Next, ask what fish are in the barrel labeled catfish. They cannot be carp, and they cannot be catfish either, or the label would be correct. So they must be carp and catfish. The carp barrel then must contain the catfish. So yeah, that one's nice and simple. But it's labeled very hard. I'm not sure I buy into the hard, easy, hard, very hard, given that some of the easy ones are difficult and some of the difficult ones are easy. But I figured this one is easy. Maybe it wasn't easy. I'm not sure. But I think it's pretty subjective. Okay. Let's see. Which one next? Okay, this one is labeled hard. There's the picture. Not really, yeah, not much to see there. Kind of funny. Lovely lady here. So the question states, at the social, everybody shakes hands only once with every other person. Altogether, there are 15 handshakes. How many people attended the social? So there are 15 handshakes, and everybody shakes hands only once with every other person. So, how many people were at the social? Take your time to count. So, I think it would help to visualize this. So let's say there's one person at the social gathering. Kind of sad. There's one person there. There are 0 handshakes. So, let's see. How can we... Okay, so... how can we visualize this? Number of people and shakes. Okay. So if there's one person, there are 0 shakes. If there are 2 people, there is 1 shake. Those are pretty easy to think about. If there are 3 people, let's think of it this way. Person A shakes with person B with person C, and person C with person A. Yeah, that's right. So there are 3 handshakes with 3 people. Now, let's say there are 4 people now. So if there are 4 people, there are 6 handshakes. So A shakes with B, A shakes with C, A shakes with D, B shakes with C, B shakes with D, and D shakes with C. So for 4 people, there are 6 handshakes. So basically, I lost my train of thought for a second. But basically, for 3, there's 3 shakes. For 4, there's 6 shakes. For 5 people, there's 10 shakes. And that one, rather than counting, because it gets a bit tedious to continue counting A, B, A, C, etc., now the number of shakes is going up by a predictable amount every time. So, for example, 1 people to 2 people, the amount of shakes increases by 1. 2 people to 3 people, shakes increases by 2. 3 people to 4 people, shakes increase by 3. 4 to 5, shakes increase by 4. So now instead of counting, we know for 6 people, the shakes from 5 people will increase by 5. So 15 shakes for 6 people. Let's see. You can see here, kind of made a table. So the increase, it's an increase of, I guess you could say, n minus 1. So, back to the original question. There are 15 handshakes. We know that at a 6-person gathering, there are 15 handshakes. Right, and the way they explain it also makes sense. Let's watch as they come in one at a time. The first person to arrive has no one to shake hands with. The second person has one person to greet. The third person has 2 people to greet. The person 4 greets 3 people. Person 5 greets 4 people, and then you add that to the total handshakes, and so on. So, yeah, that makes sense. Does that make sense to you? Yeah, that's awesome. Okay, so we did 3 so far. Let's see. Okay. Let's see. Okay, let's do this one. So here's the picture. And the question, the problem states, 5 miners charged out of the shaft as the timbers crashed behind them. Jeb was not the first out. Kane was neither first nor last. John Henry pushed out immediately behind Jeb. Preach wasn't second out. Zane was 2 men behind Preach. In what order did the men race from the mine? Okay, so there are 5 miners. Jeb, Kane, John Henry, Preach, and Zane. Interesting biblical names there. So in what order did the men race from the mine? So I'll repeat the facts. Jeb was not the first out. Kane was neither first nor last. John Henry pushed out immediately behind Jeb. Preach wasn't second out. And Zane was 2 men behind Preach. So in what order did they come out? So what is the best way to do this? So I think we can establish who is not first, right? Because, so Jeb was not first. Okay, let's see. Jeb, J, C, J, H, P, and Z. Their names. Okay, so, and then, let's see. 1, 2, 3, 4, 5. It's always easier to visualize these things, I think. And you know what I wanted to do for this video is have a whiteboard behind me. I think that would have been nice. I don't have a whiteboard, but let me know if you think I should get one. Right now I just have my clipboard here. And you can still, I mean, the benefit is there's kind of the scratchy writing sounds that the whiteboard doesn't have, but I don't know, I think it's kind of ASMR for me when someone writes on a whiteboard or a chalkboard, very, like, you know, teacherly. Okay, so we know that Jeb was not the first. Kane was neither first nor last, so he was not the first either. John Henry was immediately behind Jeb, so John Henry was also not first. If he was behind Jeb, or behind anyone, he's not first. And then Zane, it was 2 men behind Preach, so if he's behind someone, he's not first. So because now we've eliminated Jeb, Kane, John Henry and Zane as first. That leaves Preach. Okay. And then, so now we know that Zane is third because it says that he is 2 men behind Preach. Okay, let's see. John Henry was right behind Jeb. John Henry was immediately after Jeb. And then Kane was neither first nor last. So then it says John Henry was immediately behind Jeb. So if he's immediately behind Jeb, that means they have to have 2 spots adjacent. And that's exactly what this says. So so since they have to have adjacent spots, that means because Zane we know is in third, Preach is in first, that means that one of them can't be in second because first the adjacent spots are on second are taken. So fourth and fifth are the remaining spots. John Henry was after Jeb, so John Henry is fourth, and Jeb is last. Meaning that Kane is second. Yeah. So there we have it, right there. That one is hard to do, I think, at least the way I think, to not like visually represent it and draw it out. I know you have to like draw each guy. Yeah, I mean that's probably why they did this. Okay, so yeah, and that one is labeled as hard. I think that one's hard. Depends on how you do it, but okay, let's move on to the next one. Which one should we do next? This one's pretty easy, I think. It's labeled as hard, so let's see. Here's the picture. This kind of reminds me of, I don't know if you've seen Family Guy, but Lois Griffin and her dad. I don't know. I don't like watch family. Anyways. Frank and Helen's annual singles elimination tennis tournament. Let's say it's a pickleball tournament. Do you like pickleball? Frank and Helen's annual singles elimination pickleball tournament has drawn 18 players this year. How many matches must be played before there's a winner for the year? Okay, so I kind of overcomplicated this when I first read this question, and so I was thinking, you have to like start with 18 things, and then you do the like brackets down, and who won that and this and that, and then when I flip the card over, do you know what the answer is? So the answer is actually 17. And the explanation made me go like facepalm. Every match will produce one loser, and every person other than the winner will lose once and only once. 18 players makes 17 losers, therefore it will take 17 matches to have a tournament winner. So that makes total sense. And then some of these cards have like a funny bonus question on the back. This one for if you were watching this video rather than closing your eyes or laying down and you saw the picture, the card at the beginning of this question. The bonus question is, who is wearing their socks higher, Frank or Helen? Do you remember who was wearing their socks higher? Yeah, I know. That's not what you're paying attention to at all. But the answer is Frank. Take a look here. See, it's Frank. Now when I show the cards, you're gonna be all like, what am I? Yeah, you don't even know what you're looking for. It's like, okay, whose racket was blue? I don't know, but makes you pay attention, and that's what I like about these cards, just helping you sharpen your brain. So, okay, here's an easy one. Well, it's actually a hard one. Here's the picture. Oh, sorry. I didn't remember that you were scared of snakes. Okay. Professor Pithbugby finished measuring the mighty python and announced with a smile, I think we have a new record. The length of this beauty is 5 meters plus half its own length. How long, then, was the python? 5 meters plus its own length. How long do you think it is? So, it's actually 10 meters. So, the snake's length is equal to the sum of 5 meters and half the snake's length. Imagine the snake divided into 2 equal lengths. If the snake's length is the sum of one of these halves plus 5 meters, then 5 meters must be the other half. So therefore the total is 10 meters. Yeah, it makes sense when you kind of put it backwards that way, but I can understand why you thought it was 7.5. That makes sense. And for the visual bonus, without turning the card over, I'm not going to show you the card again. How many birds were on his helmet? Was that a guess? Or did you actually remember? Yeah, it is too. That's good. Okay. Let's see. Okay, this is good. This one is labeled as very hard, and I don't recall if I got this one. Yeah, I don't think I got this one when I did it myself. I looked at the answer. The question was a little hard to understand, but anyways, let me show you. This is the picture. Lauren, so this is the same Lauren who has her pigs and her ostriches, her 11 pigs and her 6 ostriches, has just unpacked her shipment of colored cosmetic jars. 1 dozen each of red, orange, yellow, green, and blue jars. Each color jar is packed in its own box. All the jars should have weighed 3 ounces, but the packing slip noted that each jar in one of the boxes actually weighs 3.1 ounces. Luckily, Lauren owns a spring scale accurate to 1/10 of an ounce. What is the minimum number of weighings that Lauren must make to discover the color of the overweight jars? Yeah, it's kind of a long question, as you can see, very wordy. I'll try to put it in my own words because I didn't understand it at first. So there's a box of 12 reds, a box of 12 oranges, box of 12 blues, box of so each box of 12, for every color there's a box of 12 jars, And each jar is supposed to be 3 ounces, but one of the colors, the jars are 3.1. So she's trying to find out which of the colors the jar is 3.1. So, how many weighings will she have to do? Like, how many times will she have to use the scale before she discovers the color of the overweight jars? What do you think? 2? Is that your final answer? 1? 3? 1? That's right, it's 1. Yeah, that's good. So I didn't get this one. So here's how. I'll read the here's how. Lauren can select 1 red jar, 2 orange jars, 3 yellow jars, 4 green jars, and 5 blue jars, and weigh all of them together in one weighing. If the scale reads 45.1, the red jars are the heaviest. If the scale reads 45.2, the orange jars are the heaviest. So the decimal will be, if it's like 1 red, it's just 0.1 times 1. If it's orange and there's 2 orange jars, and the orange ones are 1/10 of an ounce too heavy, there will be 2/10 of an ounce over, and so on. The number of 10ths of ounces over 45 ounces that the 15 jars weigh will reveal the color of the overweight jars. Does that make sense? Kind of? Okay. Let's see. Maybe I have time for one more. Do you want to do one more? Yeah, and then if you like this, we can do this again, and we can do more riddles, logic puzzles, things like that. If you want, we can do some of the visual ones, and I can show you kind of from an overhead angle, and we can maybe do some, tracing of the mazes, whatever you're up for. But I find these very fun and intriguing. Okay, let's do this one. So this one's kind of fun. Here, you can take a look at that. Amoeba troubles. That's what it's called. There, this is a kind of fun looking one. Every minute, the cellular creature splits in 2 halves, each one immediately growing to the same size as the parent. In 60 minutes, the multitude of amoeba completely fill their container. To the nearest minute, how much time was needed to half fill the container, or to fill half the container? Yeah. Not quite. I can repeat the question. Yeah? Okay. Every minute, the cellular creature splits in 2 halves, each immediately growing to the same size as the parent. In 60 minutes, the amoeba completely fill their container. So every minute, they split in half. How much time was needed to fill half the container? So the answer is 59 minutes. Yeah, I'll read the here's how. Remember, the creatures double in number every minute. Therefore, the container would have been half full 1 minute before it became completely full. So between minute 59 and minute 60, the creatures doubled, and the container went from half full to full. Does that make sense? Yeah, it's kind of a satisfying answer, actually, because it's not as mathematical as you think. I mean, it is mathematical, and in a sense, but you don't have to do some complicated solving of, I don't know, half-lives, amoeba half-lives. It's just like, oh yeah, in a minute. So between half full and full, it only takes a minute. So anyways, I like that answer. Now here's your visual bonus. I will be very, very impressed if you get this one. What time is the clock in the laboratory showing? I don't remember at all. Yeah. Do you? That's a good guess. 12:15. 12:15. And how many seconds? I'm just kidding. It just says 12:15. So, yeah. I had a few more picked out. Let's see. Well, you know what? We'll do one more. We have time. I'm only limited by my storage space. Okay. Here's the picture. Here we have Roland. So Roland is making a bracelet as shown in this drawing. So I guess maybe this one kind of requires you to look at it, but I'll describe the picture. So if you don't want to look, that's okay. He has four sections of chain to link together. So he's trying to make a bracelet that's a loop of chains, and he has 4 sections of 3 links linked together. So there are 4 sections of 3 links. It takes 15 minutes to cut open a link and weld it back together. And thus, he would like to cut as few links as possible. How quickly can Roland complete the task? An hour? What if I told you it's shorter than that? 45 minutes? Is that your final answer? 30 minutes? I don't think it's 15. 45? Okay. And how? Well, let's see then. It will take Roland 45 minutes to complete his task. Okay, so here's how. Roland needs to, and the bonus question is not a visual bonus, so you can look at this if you'd like. Okay. Roland needs to cut one of the 3 link sections into its individual links. Using the 3 loose links, he can join the 3 remaining sections together. Taking 15 minutes to cut and weld each of these 3 links, Roland will need 45 minutes to finish. 3 times 15. So, yeah, I guess like on first glance you might think, oh, an hour, because like you unlink, link from section 1, a link from section 2, a link from section 3, and a link from section 4, and then you weld those back together. But actually, if you just take one of these 3 link sections, cut it apart, you're only have to do that 3 times, and then use those links to link the remaining 3 sections together. Yeah, so I like that one as well. So the ones where that answer is like, oh, that's satisfying. Those are the ones that I like. So yeah, I hope I didn't make any errors, but please point out if I did. Please let me know if you would like to do this again, and if you got them right. Which ones you liked, if you found them difficult, easy, yeah, whatever, let me know. And I will see you soon, and I hope you sleep well.